All right. So we've struck the hour. We've got 30 folks on the line. I say we get going. Um, Welcome, everybody. This is our kickoff session. Um, After the ETC conference that happened at Iowa State, we did a pre-conference session around AV over IP, and it was well attended, and folks appreciated the content and the presenters that we were able to bring to you. And Karen and the board have thrown together then a task force. The charge is to bring you content. We're going to try to do that on a monthly basis now through when the next annual conference is at NC State. So the team that's here today, myself, Jeff Levesque, who you hear quite a bit about, Steve Bogart from Atlona is here as well. A couple others on the committee. If you're here, I didn't see in the gallery preview, but there's a couple of pages. So thank you all. We're going to start with a session today that's about key terms and business cases and things like that, just to kind of set the stage for AV over IP. And then in the rest of the series through the rest of the year, we'll go more in depth. We'll have special sessions on, certain buzzwords and trade names and different things like that, and try to bring you a holistic picture of everything that AV over IP entails. It's also something that we don't intend to do in a vacuum. We are going to send out some kind of survey or request for your feedback to make sure that we're covering the topics that are relevant to you, that are important to hear about, and that you want to make sure that we include. And also watch for our upcoming schedule. We've got a date penciled in already in January. I believe Steve is going to be working on the content for that. So hopefully this becomes a regular thing, and we're glad you're here. So as Steve put in the chat, feel free to put any questions that you have in the chat. We're kind of informal and can, take tangents and receive questions as we go, if that's how you'd like to go about it. And without further ado, I'm going to hand things over to Jeff. Jeff Levesque is the lead information technologist at the University of Rhode Island. He was also gracious enough to be one of our pre-conference workshop presenters, and he's here today to kick off our series. So welcome, and thank you, Jeff.
No problem. All right, let's get this going. Yeah, so Jim already did a nice introduction about myself. So I am Jeff Levac from the University of Rhode Island. Lead information technologist. My job title doesn't tell you a whole lot of what I do. I kind of do it all on campus. I design, engineer. I'm actually in charge of the AV networks now. I program. I'm last line of troubleshooting on campus. So I kind of do it all. We're responsible for about 150 classroom spaces, plus conference rooms, plus all these other spaces that just seem to keep popping up over and over again. We are a very small team on campus. We're 5 people total. Myself, my manager, we have 2 people who do special events, and then we recently hired someone to take over the minor troubleshooting off my plate. So we're a very small team. We manage all of campus. So as we're going forward and doing this, I have put a lot of AV over IP onto my campus. So if we're going to do something, it has to be something that's going to be very effective for us on campus, because big campus, very few of us to deal with. So today, things I want to go over with everyone, kind of give you an idea of where we're going. Going to go through some basic definitions of some introductory networking terms, considerations as you're going ahead and thinking about this. Talk about some setups. You can go really simple. You could also go really complex. Go through use cases, and then costs and benefits. Because if you're going to venture into this, there are costs to doing this. There are a lot of benefits to doing this also. So first thing, if we're going to talk about AV over IP, we really should go ahead. What does this stand for? So if we're dealing with AV over IP, that's the transmission of audio, video, and control data over a network, such as a local area network, a wide area network, or the internet, using network protocols. Really don't recommend the internet. But it is technically possible. And the goal is to do this using standard networking equipment and protocols to switch and transmit the video and audio signals, and control signals. So the goal is to do this using standard network switches. We really don't want to have to get into specialty equipment. So you might have noticed we talked about protocol. So a lot of what we're going to deal with is dealing with what's the networking protocol? What do we mean when we're actually doing this, when we're using AV over IP? So if we're talking about protocol, that's a set of rules that's going to determine how we're sending our data. How is it being sent? How is it being received? All over the network. So if you're going to send some sort of data, some sort of protocol, we're really talking about whatever language the network is using to talk to one another. And there's a lot of things here. So if you're going to send data, some things to be concerned about: syntax, how are you formatting your data? Semantics, what are the rules and norms for sending your data? What's the timing? What's the synchronization and coordination between devices? Kind of need to keep an eye on timing, because if you're sending data, you would like your data to arrive in some sort of coordinated effort. Sequence control, we want to make sure it's coming in the proper order. Flow control, we want to make sure we're getting data in some regular interval and we're not flooding the switch. Error control, how are we going to fix errors? Because errors are inevitable. So how are we going to correct those? How are we going to fix and take care of them? And of course, the last part, security. Um, so these are our key elements when we're talking about sending some sort of data across. Here's our network protocol, just our rules. As we're going to dive deeper into this, well, if we're really going to look at how we're sending this data from place to place, we're going to get into the OSI model for this, the Open Systems Interconnection model for how we're going to be sending data. Anytime you're using that internet network, you are using this whether you want to or not. And how this goes, you type in on your computer, you're going to start on layer 7, go all the way down to layer 1 on your device, send that over the network, and when it gets to the other side, we build it back up all the way from 1 back to 7. If we kind of peel away these layers, so if you're looking at layer 7, you're starting on your application layer. In this case, we're in Zoom. So Zoom's our application layer. It's going to initiate the communication with our network, including what protocols, so what networking rules are we using, how are we manipulating that data. So we're going to take what we have and convert it to computer readable network data. Once we go ahead and go through the application, we then go to the presentation layer where we're going to take that data and we're going to translate it, compress it, and encrypt it in order to get it ready to start to be sent. This is where you will hear and talk about things like TLS, transport layer security. That's where you encrypt data and transit over the internet. Um, there's also SSL, secure sockets layer, where you're going to encrypt and authenticate data sent between two devices. Once you make your way through the presentation layer, you go down another layer to the session layer. This is where you're actually going to initiate and terminate connections between two devices interacting on the network, making sure that you're not overusing or underutilizing your resources on the network. Um, all of this, we still haven't even begun to send the data. This is all just preparing to send the data from one place to another. Uh, Finally, we get to layer 4. Here's where we're actually starting to send the data. Here's our transport layer where we're actually sending data from one end to the other end between our devices on the network. Where we're making sure that we're not losing data, it's not getting misconfigured, it's not getting corrupted. Typically, there are two methods to talk about when you're sending data on this transport layer. You got TCP, transmission protocol, control protocol. Um, that is a very slow but accurate way of sending data. You're constantly handshaking to make sure that that data packet has arrived. The other way to send data on layer 4 you will typically hear about is UDP, User Datagram Protocol. That's fast. That just sends the data everywhere. Kind of like turning on a fire hose and water just goes everywhere. UDP is very much the same. You're turning it on, you're sending that data everywhere. You're not checking to see if anyone wants it. You don't care if they got it or not. You're turned on that fire hose and you are just sending the data if you're using UDP. Once you get to the transport layer, once you're sending that data, we go down a little bit further. We're looking at layer 3, which that's our network layer. That's where you finally can start talking about IP addresses. That's where your IP addresses take place is layer 3. Um, what, and your logical addressing. Um, if we go down another layer, layer 2, that's your network switch layer. Here's where your data is interacting between two devices on the same network. VLANs, we're going to define that in a little bit. Those are layer 2. Typically, this is where you're also dealing with MAC addresses, layer 2. We're down on layer, this layer. Layer 1, bottom layer, here's your copper. Here's your physical layer. You're finally at your copper, your cat cables, your fiber. It's all on layer 1. So every time you are sending data, you're starting at layer 7 with your application, and you are just working your way all the way down to the copper, and then working your way all the way back up every time you're sending something from one place to another on the network. This is just a really helpful way of making sure you're understanding where these things that are going to be coming up are coming in, as we dive deeper and deeper into this. As we're sending data, our data transmission. So that's how we go about sending data. If you're going to send data from one place to another, typically there are 3 ways we will transmit data between devices. One is unicast, that's one-to-one. It's a very efficient method to transmit data. You send it from one device to another specific device. You have multicast, which is one-to-many. We're going to break these down even further. Then you also have broadcast, one-to-all. Everyone has its very own advantage. They all have their own disadvantages. Again, unicast, that's a one-to-one, very useful. You're going to send something from the green block to the orange block, one data stream from green to orange. If you're going to use unicast to try to send it to multiple devices, that means you're going to start replicating data streams. That means you're going to send one data stream to orange, you're going to send another one to one of the blue blocks. You really start to generate a lot of data on your network if you're going to use unicast to send it to more than one device, which not very efficient if you're trying to get that data to multiple places at once. Kind of the opposite side of that would be if you're going to, well, let's broadcast it then. Let's take our data, let's send it to everywhere. So now we're going to send our data from the green to everything on the network. So every block is orange, we're sending it to everyone. What gets fun about this, there's a lot of data here. We're sending it to all ports, whether you want it or not. And if this is a big data packet you're sending, you're going to start flooding your switch. Your switch is going to slow down because there's just a lot of data flowing through it. You send it whether it wants the data or not. Kind of best way to think of broadcast, it's really just like a TV network, at least old school, analog. You have your TV stations that are putting out their signal over their broadcast antenna, and that's because that is going to every TV whether it wants it or not. Broadcast transmissions in IP networks, same deal. We're sending that data and it's going to everything in that network whether it wants it or not. The compromise between the two is multicast, one to some. We're using less data than broadcast. It's much more efficient than unicast because we're not replicating that data stream every time we want to send it to a new device. This is our best option for AV over IP. We go through all that to get to what we really want to talk about is multicast. This is where the heavy lift tends to come for people when we're talking about implementing AV over IP within your classrooms, your spaces. This is where we're going to spend a little bit of time trying to break down what multicast is, how it works. We're going to at least put some definitions out there for today as we go through other webinars in this series. We're going to break this down. We're going to get even further into depth about most of this stuff. So if you're going to set up multicast, that means you have to somehow properly handle multicast. Um, Depending upon your school, some network teams know how to handle multicast. Some network teams don't want to touch multicast. It really depends upon your environment. Every environment tends to be different. I will say at my school, my networking team, um, they really don't want to handle multicast. They're more than willing to, but they don't. So I tend to be setting up all my own networks. It really depends upon your comfortability with this. So if you're going to start setting up a multicast network, there are some things you need to be aware of. If you don't properly handle your multicast traffic, you can flood your network. And luckily, there are tools to help you handle multicast traffic. Um, One of the first things we need to figure out is while we are sending this data, we're sending it from some sort of encoder. We're trying to send it to decoders. If we're going to do that, how do we know which decoders we're sending it to? This is where we need to start talking about kind of managing groups. So when you're dealing with multicast, a common term, IGMP, Internet Group Management Protocol. This is just a communication protocol. It's a communication rule that's used by hosts and routers to establish a group. You figure out who wants this stream. If you want this stream, cool, we put them in that group and they can start getting that. The other way to manage groups is PIM, Protocol Independent Multicast. There are two types, dense and sparse. Typically, you don't deal with PIM unless you're really trying to send it over the broader network. If you're containing things to your local switch, you're typically going to deal with IGMP. Um, if you're getting into PIM, that goes a lot. That goes further. That goes further. I don't deal with PIM. I don't want to. Dense, because two types, again, PIM, you get dense, you get sparse. Dense is suitable for groups with lots of endpoints. Sparse is suitable for groups with very few endpoints. That scales well. Dense doesn't really scale well. So again, you can do tons of reading about those. I don't bother with PIM. I'm typically dealing with IGMP. If you're setting up IGMP, something you need to figure out is, well, who belongs in what group. And to do that, you use a querier. A querier is a network device that sends a query message to discover which network devices are members of any given multicast group. It really is just something that's asking every endpoint, do you want this? Yes or no. If you do, cool, we'll put you in that group. If you don't, we don't put you in that group. The rule with queryers, there can only be one. There's one query on any given network. You don't want multiple queries. That's when you start having issues. You can pretty quickly tell if your query is not set up correctly too. That is when you will start to find you have AV over IP issues. Usually when you start to see things not working right, checking your query is usually one of the first steps I will do. The other key thing with IGMP is you want something to kind of want a snooper. You want snooping. That's the process of forwarding data only to the links that have solicited them. The switch by default is going to flood multicast data to all the ports. It's kind of a switch feature. Snooping is a switch feature. It listens in on the IGM traffic and just kind of maintains a map of where this data should be going. Your query determines who belongs in the group. Your snooper is kind of your map, what should be going where. The other part to help you handle multicast more efficiently is to set up a VLAN, a virtual local area network. That is just a virtualized connection that connects multiple devices and network nodes to form different LANs into one logical network. It is a virtual network. You assign whatever ports you want to that VLAN. Those are the ports that are going to get that data. VLANs are very, very helpful when trying to set up multicast. Um, these are the big terms that you will hear as you work on setting up AV over IP networks. These are terms that come up over and over and over again.
Hey Jeff, I'm curious, between IGMP configurations and PIM configurations, what do you think the lay of the land is or the market share is on those? Are you at an organization that you think might be an outlier that you're not using PIM, or do you think it's less common everywhere?
So that's going to really depend upon your network environment. If your network team is the one handling the multicast traffic on your network, if your AV over IP systems on your actual campus-wide network, I'd be more, I'd expect to see more PIM. Whereas if you're kind of setting up your AV over IP systems as a kind of a room by room basis, I would expect to see more IGMP. Um, I get a feeling IGMP is much more common than PIM. Typically, a lot of the groups I belong to, everyone's always asking about IGMP. Very few people are asking about PIM. So,
Sure, fair enough. If anybody else has questions, feel
yeah,
free
please
in the
before.
chat, unmute, whatever you think makes sense.
Hey, can always come back to questions. I have no problem coming back. I will answer them the best I can. Um, the other big thing that we need to be concerned about as we're dealing with AV over IP, if we're going to start sending video streams, is codecs and compressions. If you're going to try to take a video stream and send it on a switch, it can be really taxing. Um, this is where we're going to start talking about codecs and taking and compressing our data. If you're going to take a 4K video stream and try to send that on a normal switch, you're going to have a problem. A 4K video stream itself, uncompressed, is typically about 12 gigs per second. Most network switches that you're going to run across, the ports are 1 gig ports. 12 gigs 12 gigs of data does not fit through a 1 gig pipe. So in order to handle this, in order to make this work on a regular network switch, we're going to have to compress it. And to do that, that's a codec. Codecs can be hardware-based, they can be software-based. We're just going to compress and decompress large amounts of data. There are many different codecs out there. Most of you are familiar with all sorts of them. We got JPEGs, got PNGs, um, image codecs. You have audio codecs, MP3, AAC, some more common video codecs that you may know of, H.264, MPEGs. Those are all codecs. Those are all ways to take data, compress it to make it much more efficient to send it over the network. Your codec's just going to take that raw data coming in, transform it more compact. You're going to send it off to the decoding device, which is going to unpack it and put it back into its raw form. Now, when it comes to dealing with codecs, there's always a trade-off. Kind of two kind of codecs out there. You have your lossless codecs and you have your lossy codecs. So a lossless codec is one where you're not going to lose any of your data between that compression and decompression. A lossless codec is going to be typically much more a lower efficiency. They're going to get a little bit of a lag on a lossless codec because you're not losing any data. So you want to make sure you're accurately encoding and decoding that. On the other hand, you can have a lossy codec. Those are really high efficiency because they're going to encode and decode, and they don't care if you've lost some data along the way. So it's really something to pay attention to as you're looking at um, what AV over IP system you're implementing, what codecs are being used. Is it lossy? Is it lossless? What's its efficiency? Because that will matter at the end of the day. There is one other piece to this, as we're going forward before I can kind of start getting to more of actual AV over IP, kind of the last little networking portion for today. We're sending a lot of data between all these endpoints. Um, Typically, and at least the AV over IP devices that I use, I'm typically looking at 750 megs per second as I'm sending that down my switch. So it's a lot of data that I'm sending between endpoints. And something we need to be concerned about is making sure that all this data is synchronized between all parts of the system. We don't want packet 10 to arrive before packet 8. We really want to try to make sure these packets are arriving in order. So another key component of this is PTP, Precision Time Protocol. Just our rules for clock synchronization throughout a computer network with relatively high precision. On a LAN set up properly, we could be in the sub-microsecond range, which is really good. That's very helpful. You want to make sure that your packets are arriving in order. Um, PTP, again, I typically see this much more when dealing with audio than video, but it is something to be concerned about. Again, this is just another multicast protocol. On that list of protocols I had earlier, here's another one we could throw in here. Um, if your multicast is not set up properly, you will see PTP errors. There's another way to tell that your multicast network is not set up right. If your audio keeps cutting out, you have a multicast problem that needs to be investigated a little bit further. All right, that is the last of these networking things I want to get into today. As we This could go on for so much longer. Um, let's get to some of the more, as I think of some of the more fun stuff, not so heady. So, if you're going to set up an AV over IP network, there are a couple different options for how you could set up your AV over IP systems. Are you throwing it on the campus-wide network? Typically, if you're going to do that, that's where the networking department is going to start providing the switches and the drops for you. Networking is going to set up your VLAN. Networking is going to take care of that other side for you. Or are you going to put it on a private network? Are you going to drop a network switch in every classroom where every AV setup is going to have its very own dedicated switch configured for that installation? This is not connected to your campus-wide network. It is just local to that room. Or you could do a mix. You could kind of do the hybrid option. You provide your own switch, but actually have an active connection to the network switch from the network switch to the campus network, where you might get a trunk to the campus network, um, or your switch might have specific ports that can access a campus VLAN. One of the benefits to moving to a hybrid situation is you can actually provide monitoring capabilities. Um, on my campus network, I'm actually running a hybrid model. Some people will call it an island. Some people will say you have a drawbridge. Uh, Take your pick. Essentially, you have a way to get into that system. You're still using your own switch, but you can actually go in and see what's happening. My campus networking team, again, they don't really want to manage the multicast, which is fine. I will not put that on them, but they actually provide me a trunk to the rest of campus. So I can trunk off that switch and easily access my AV over IP systems. Um,
So Jeff, do you have any where you are sending AV over IP from one room to another room, or is most of it self-contained?
Great question, because I actually do have a few places where I'm actually sending it from one room to another. Um, right there, use cases and scenarios for where you're going to use this. Like, why would we use AV over IP? It's very flexible. You can use it for almost any situation. For example, on my campus, we actually have it set up in one building right now. Going to be slowly rolling that out into a Memorial Union starting this summer, where we're actually going building wide. So in my URI Welcome Center, that whole building is on one AV over IP network. I have multiple switches in there where we can actually send any video, audio signal from any room to any other room. So I can send what I want from that main big room called the Hope Room, where a lot of university functions happen. I can take the audio in there. I can actually send that all over to the lobby. Very easy to do audio overflow in that room. Next up, actually, in that building is to get AV over IP decoders behind the digital signage in there so they can actually overflow video in there. So you're not necessarily, and again, I am running that as a hybrid situation. I can peek into that welcome center at any time I want and see what's going on, but I am still running my own switches in there. Another use case for AV over IP, your auditoriums. And here's another case. So these are some auditoriums on my campus. These are the Chafee odds. There are actually two more that I just did not want to put up there. I have 5 auditoria altogether. They're actually all linked via AV over IP. This is actually my oldest AV over IP installation. This happened back in 2019. The large one up on the upper right, that's a 500 plus seat auditorium. And then there are 4 smaller auditoriums where I can take if I have a big event happening in the large auditorium, I can overflow to all the other auditoria as needed. And again, it's hybrid. I can peek into there at any time, see what's going on. Or another case doesn't necessarily need to be hybrid. This is our latest installation. This one just happened this summer. This is another AV over IP installation that we did on campus. This is Kirk Odd. This room, I can't share it anywhere else. So you really have your choice what you want to do with each case. Yeah. You can use it in your classrooms. Our classrooms from here on out are all AV over IP. AV over IP. These were just installed this summer. Again, this is a very flexible way to do AV. You can use it however you need to. This is the best part about AV over IP. I can use it in conference rooms. That conference room right there, we have fully AV over IP. We can use active learning centers where most people automatically think to put AV over IP. Yes, it makes a lot of sense in an active learning center, active learning classroom. You can really install this anywhere. Kind of your limit. You're just limited by your creativity. I actually had somebody come to my office a couple weeks ago and ask me about using AV over IP to essentially put digital signage in throughout their wing, where they just want a computer in their office and they just want to put a encoder on that and put decoders behind all the signage and just run it right from their office, which, yeah, that definitely works. There's already copper, there's already network ports back there. It's just a matter of routing them from the closet. So again, it really is your creativity that limits what you can do with AV over IP. As you start putting more and more AV over IP parts in, of course, something that comes up often, what are the costs to doing this? What are the benefits to doing this? If you're going to get this started on your campus, yes, there are costs involved in it. And they're not just financial. Everyone kind of hangs up on the financial side of this. Yes, there's cost to doing it. You're kind of changing how your room operates, right? You're going from however you're using, are you using HTTP right now or using some other method? So you're going to be changing that. You're going to have to be concerned about network switches. Are you providing your own, paying for network drops? The one thing I want to tell people, and I know I got a lot of weird looks for this at the annual conference, going to AV over IP does not necessarily mean more money. Um, all my AV over IP installations I put in on my campus, apples to apples comparison, I haven't spent anything more than I would putting HD base T in. My apples to apples comparison, I'm spending the same, if not less, by moving to AV over IP. It really takes careful planning as you're going forward to make sure that um, you're not blowing your budget. Pretty easy to blow your budget if you're not paying attention, but if you watch your budget, watch what you're doing, you can do this without overburdening your costs. Now, I said there are other costs. The other cost to doing this, well, that's your personnel and time costs, right? If you're going to move to AV over IP, that means you got to start looking at, well, what's some training to do? Because I might not have been spending more money on my campus, but I know I had a lot more training to do. There was network training, different skill sets. Something we've come across as we've put more AV over IP in on our campus. My audio engineer's been doing a lot of learning. He's really good at dealing with analog audio. Digital audio is a little bit of a different beast. So, we got some different skill sets that we're working on picking up now. Um, yeah. And then, of course, benefits to putting in an AV over IP solution. These are huge. So scalability, add, remove endpoints as you need to. When I was installing my auditorium over this summer, we actually, as it was designed, we were in the room taking a look at everything. We're like, that screen's really high up. It'd be nice if I put a screen down lower so the people sitting on, in the first couple of rows can actually see without craning their neck all the way back upwards. Well, because it was AV over IP, it was really easy for me to add another endpoint to that without having to go back. Did I have to go find, okay, was that an 8 by 8 matrix? Do I have to go to a 16 by 16? Like, without doing all that, it was really easy. No, one more decoder. That's all I needed to do. If I had room on the switch, perfect. You're no longer limited by defined inputs and outputs. You have much more control over your inputs and outputs. Really easy to scale. And of course, shared resources is a lot easier. You're sharing resources now, just easier. Again, benefits. Your first one's probably, there's going to be a little bit of a lift installing your first one if you don't have any, but every subsequent one gets a lot easier. At this point, at this point, I have a legacy HD base T room to install over the winter break, and I have to go back and think, how do I do that again? I'm much more rather be installing my AV over IP rooms by far. Um, Again, you've been another benefit. Already mentioned it before, but going to mention it again. Flexibility. You can reimagine your spaces. If there's a change in mission, it's really easy to change your system around goals, or if you're going to turn over the room, you want to totally redo it. Easy enough to do with AV over IP. The other big benefit, especially we found on our campus, was management because it's all network based. So now I got usage data, I got downtime, and uptime. Troubleshooting user issues has actually become really easy. My students who work for us love it. They can log into a back of a system and see exactly what's going on. We have a professor calling saying HDMI is not displaying. They can look in the back and ask the professor, have you actually plugged in your HDMI? Because I don't see an HDMI signal coming into the system. And surprise, surprise, no, I haven't. Can you plug that in? And it starts working. It really has really helped our students. We are getting less trouble tickets now, by far. And the other big benefit, it builds campus partnerships. You can build a better partnership with your IT folks. My campus, we are technically in part of IT, but I have a much better relationship with my networking guys. I already did. even better now, your facilities people, it, just a better way for your campus unit to get more integrated on your campus. Um, what's that? Not bad. Not bad time-wise. Kind of where I'm stopping with what I have for things. Again, just summarizing this. Highly flexible. I'm not going to summarize the technical stuff because just technical. Um, Highly flexible, many different use cases. Again, upfront costs, but the benefits to moving to it are very, very numerous. All right. And with that, that's all I have at the moment. So I know there are questions in the chat. Um,
The other thing that we can do is there was a panel discussion from some of the other morning presenters that we closed out the morning session with at the pre-conference session. We could turn those into a group forum and chat about those amongst the room here.
yeah.
So I guess the first question to speak to is about what's involved in converting a legacy or a traditional system, a non-IP system, to AV over IP. And you mentioned this a little bit. It depends on what you're starting from, right? Are you having individual extenders? Would you, have an HD-based T system where everything kind of home runs to a switching appliance anyway, and you're just changing what the flavor of that appliance is? So it is a nuanced question. There isn't one silver bullet that answers it all. But I feel like when AV over IP came out, a lot of the company's marketing teams really leaned into you can send anything anywhere. And as soon as you got your networking folks involved, that was terrifying. And the answer was absolutely no. And it was, 10 years ahead of when that kind of a concept might have been acceptable. But instead, if they said, use these these IP endpoints, and instead of having your, 8 by 8 or 16 by 16 switch in the middle, you have a network switch instead. And if the, protocols are compliant and you can set them all the way that you want, it might even be the brand that your networking team is already used to being the administrator of, and you have some efficiencies and advantages there. So I feel like there'd be more adoption and more market share in AV over IP now if the first thing we heard about it wasn't so scary.
Yeah, absolutely. Yeah, and it really you hit the nail on the head. It depends upon your legacy system. If you have an analog system, it's going to be a lot harder to convert that directly, reusing copper and whatnot. But if you have an HD-based T system, which we do on our campus, so it's been really easy for us to convert over, again, all our home runs. So it really depends upon what kind of system you're running now as you're thinking about doing that conversion.
Well, and if you have an analog system that you're looking at upgrading, you have to upgrade it anyway. It's not like
Yes.
going to AV over IP is two hops. You're already going to be pulling category cable all over. You have the choice of what your endpoints are and what the core and your switch is in the middle now.
Yep.
Is anybody on the line doing that anything to anywhere, broadcasting across buildings, between rooms, doing overflow, that sort of thing? Curious, in your auditorium installs, Jeff, you'd mentioned that they were some of your earliest. Were they pre-COVID? And for overflow and things like that, you might use Zoom or your LMS or lecture capture system instead? Would you have done those differently 5 years later?
Yeah, those were installed pre-COVID. And we actually um we designed it like that at this point. We actually have a really good um classroom capture system in place now that we kind of would do for some overflow now. Um, but again, depending upon how you're set up, like in our welcome center, if I decided to use that for overflow, that would fail pretty horribly considering it's a contained building. Um, right. That I can't imagine doing that or using Zoom in the welcome center, being able to instantaneously send everything everywhere. So if you walk out of the room and into the lobby, you're hearing exactly what's going on in
It comes
time.
down to late.
Yeah, that latency would just not be acceptable. Um, Even in those Chafee odds, those are in our Chafee building, even I'm not even sure if I'd want to put latency in there because again, you can walk out of one odd, walk 10 feet into the other odd. And depending upon what you're using and upon latency, you really might be yeah, in for a little bit of a shock.
Sure. So the second half of that question was what can be kept and what has to be replaced. Of course, all your video endpoints, your source devices, your destinations, your displays, things like that, are kind of agnostic to what the system and the cabling is in the middle. You'd be looking at how do they plug into the switcher? How do they get transported and switched and distributed and decoded? That's where you'd have two choices of flavors, and AV over IP would have a play here.
Yeah.
Can't think specifically of a device that would be, you know, superseded or unusable in the other environment. If it has an HDMI cable or some kind of digital video that you could have on an encoder or a decoder, um, you're in the game still. So it wouldn't age out anything unless it had a VGA connection on it, probably.
Yeah.
And still, you'd probably do VGA to HDMI conversion and put it into AV over IP that way.
Yeah, exactly.
A couple of questions about choosing brands and trade names, which flavor you're going to go with. Of course, the Trons have their solutions, other companies have their brands. Dante is pretty synonymous around the world. It now has a video flavor, but there could be a table of all of their specifications and the comparisons. What their frame rate is, what their bandwidth limitations are, what their latency is, and that may guide some of your decisions. Otherwise, there's a lot to be said for ecosystems you're already in or using or know how to program, right? If you program one system's, control code, you may or may not want to learn a new one to implement a different company's, AV over IP hardware. So that's a complex question to answer. There isn't a single one, but laying out the specs and comparing them and then weighting the scale with pros and cons of what you already know and what you're willing to learn would help inform that better. So Chris brings up a good point about why swap what he's calling baseband system for AV over IP. And this is kind of a callback to when you were doing definitions, Jeff, about these being codecs. Um, right now, if you're within the distance limitation or you have an extender that you're happy with and trust and you don't need more features than an HDMI cable, a direct video connection is going to be the highest fidelity pixel per zero loss way to go about this. Anything that you do over the network is going to involve compression. There's going to be that encoding codec and the decoding part of it. So that portion of it, I guess you could label as being compromised, but we're also not doing critical viewing, theatrical 60 frames per second, things like that when you're showing a professor's 4x3 PowerPoint that changes every 6 minutes. So the capabilities of the system versus the use case, there might be an efficiency there or a cost play to consider different kinds of solutions.
Yeah, I can also say that with the legacy systems, if you only spec'd it with like one output, and like this hit us in COVID on campus was because we were still using legacy systems. We had one output to the projector, actually two, one to the projector, but then the second one was tied to a preview monitor for a room computer. But then we had to go ahead and, add recording in for lecture capture. Well, I can't do that on that legacy system. I'm tapped out right now. And there was no way to do that without trying to use, distribution, HDMI distribution amps, and it failed horribly. Whereas AV over IP, I can add that in now and not have to go back to the drawing board and try to redesign my system from the ground up. So just something to keep in mind. Your classroom and this iteration, cool, you might be good with it exactly what you have, but if something comes down the pipe that you really need to, add more inputs or outputs, it's a lot harder with those legacy systems.
And there's some comments in the chat to that effect too about, if you need one more input. Right now, if you buy a traditional AV switch, it probably comes in, 2x2, 4x4, 8x8, 16, 32, etc. If you need, a 9 by switch, you have to double the amount of inputs and outputs that you're buying. And you may not need that. If you've got an HDMI input on one of those video switchers, that means that there's 8 or 16 or however many encoders, because a lot of AV systems are using a similar backplane and network switching and codecs and things like that to do the switching. So it's happening inside of a black box, and you don't have to worry about network management. Might be capable of higher bandwidth than your networking folks want to hear about, but inside that matrix switch, the same concepts may still be at play. And if you're doing this in a modular format where you can buy one more encoder, you don't have to jump from an 8 by switch to a 16 by switch and incur all that expense. You can also change and replace 1/8 of that switch instead of the whole thing when it goes belly up. Less SKUs on the shelf. There are many efficiencies.
Yep. Oh yeah. That's a very good point. My spare parts closet is much smaller now than it ever used to be. So,
Karen asks about if the cost is a wash, what's the downside? Um, it is arguably, compression where you could have full fidelity with a direct cable, but you've got install, opportunities with cabling that may already be installed. An example that we had at Notre Dame years ago when COVID happened, we had to add a camera to every room, and we didn't have the time to pull copper in 200 new places, but we already had a network jack at the projector. That became the camera input. It went to the IDF closet. We were able to route that to the bridge that was at the computer in each room, and we didn't have install cables then. So sometimes you can solve installation problems with using copper that already exists.
yep. Yeah.
Um,
And I will
Please,
say if it costs the same, but the cost difference is negligible. Again, the only downside, and some that might be a hard ask for some people, is the personnel side of life too, because you are changing how your rooms operate on a core basis. So there's some training that's going to go involved if you're going to start moving to AV over IP, just to make sure you can properly service those rooms.
let's talk about service for another second. Did folks on your team have to skill up? Did you teach your student employees new tricks? Did you have to fight battles with information security to get them access? What kinds of things did you learn there that you didn't expect before?
Um, yeah, there's definitely some skills that my students have to learn. We're still working on that right now. Just again, the nice part is because everything was on the network, I was able to build them a single pane of glass so they can see everything that's happening in the room. So in terms of that, it's a lot easier for them now to take care of a room. But if I'm sending them into a room and there's certain parts not working. Before it was a lot easier just to unplug that, plug it back in, it should all come back. Now it's like, oh, well, it's all on the network. So which, which network port are you trying to make them power cycle? Just there's some definite skills that need to be learned there. Other members of my team, we're still working on that. We're definitely still working on that, getting everyone's up to speed with networking um, protocols, because again, we're operating our own switches, so I can call my URI networking guys, but they don't necessarily know exactly what I'm running. Um, so there's some learning to be done there, but once you get it, again, I don't want to go back. So it's a lot easier now.
And did you have any of those battles with InfoSec? Were there any points where it's like you want to give who what access?
Amazingly, no. And that's because I've been building up a very good relationship with my networking guys for years now. So I've always tried to work very closely with them. Um,
You
anything
built
to do
trust
with the network.
already.
Yeah, yeah, we have a very good back and forth communication with them already. So I didn't have to really fight that battle. The only one who gets that sort of access anyway is myself, and I have a good relationship with them already. So that wasn't a hard ask.
Some other good tidbits in the chat. I think we've touched on most of them. Any outstanding specifics that we need to make sure that we brush on before signing off here?
I don't think so. I know I put up our next one is coming in January.
Yeah.
Um,
Do you have a preview blurb for that ready, Steve? To put you on the spot out of nowhere?
Ooh, I love out of the spot out of nowhere. No, so it'll be very much following what we talked about at the annual meeting.
Mm-hmm.
But feel free to send me your things you want in more depth or questions you want us to cover deeper. Um, networking can be scary, but you know how you learn? You go break stuff and you figure out, I'm not going to do that again. And that's how you learn. I mean, AV will, in my opinion, eventually all go to some sort of network, whether that's SDVoE or the traditional 1 gig or whatever. I'm not sure what standard's gonna win out, but I think the balanced chipset bandwidth discussion is going to be really interesting over the next couple of years with USB 3 and what we're trying to push over that pipe.
Yeah, I tend to agree. I wouldn't put a date or try to time constrain it, but I think we're headed that direction generally as well. Absolutely. Great. Well, thanks everybody for attending. We appreciate your time. Please think of this as an interactive series. We don't have what we're going to do in a black box and it's top secret. We're going to poll you for what topics you want to hear about, what things you want to make sure that we include. So after the leadership team for the task force meets again, we'll have that prepped and be able to send it out, and watch for future dates on your calendar. We'll keep a good thing going. Have a good day all. Thanks.
Thank you all.
Thank you.
I don't think we have any after business anyway, so I will see you all later too.
Sounds good.
Take care.
Yeah.
See you guys.
Thanks again, Kelsey.
No problem.